Have you ever wondered how computers communicate with each other? It's through something called computer networks. Picture this, a bustling city filled with people. Now replace these people with computers, servers, printers, routers, and switches. The roads that connect them all, those are the networks. Just like a city's infrastructure allows people to interact and share resources, computer networks connect multiple computing devices, enabling them to communicate and share data. And these devices, they're referred to as nodes. They're the inhabitants of our city, each with a unique address known as an IP address that identifies them in this vast digital metropolis. But unlike a city, these networks aren't constrained by geographical boundaries. They can be as small as your home or as vast as the entire internet. So that's what a computer network is. But what makes it work? Let's dive deeper. To understand how a computer network functions, you need to know about its key components. So let's dive right in, shall we? First off, we have these are the devices connected to a network. They can be anything from your personal computer, servers that store massive amounts of data, printers, routers that direct data traffic, switches, and other devices. Essentially, any device that can send, receive, or process data can be considered a node. Next up, we have these are the communication channels that connect the nodes. They can be physical wires, like the Ethernet cable you might have plugged into your computer, or wireless connections, like the Wi-Fi signal you use to browse the internet on your phone. Links are the highways of data, transporting it from one node to another. Now let's talk about. These are sets of rules and standards that govern how data is transmitted over a network. They ensure that all devices on a network can understand each other and work together smoothly. Examples of protocols include TCP/IP, which is used for internet communications, HTTP, which is used for web browsing, and FTP, which is used for transferring files between computers. Moving on, we have this is a unique numerical identifier assigned to every device on a network. Think of it as the mailing address for your device. IP addresses are used to identify devices and enable communication between them. When you send a message or request a web page, your device's IP address is used to ensure the data gets to the right place. Next in line is the OR domain name system. This is a protocol used to translate human-readable domain names, like www.google.com, into IP addresses that computers can understand. It's like a phone book for the internet, turning easy-to-remember domain names into numerical IP addresses that computers use to communicate. Last but not least, we have This is a security device used to monitor and control incoming and outgoing network traffic. Firewalls act like bouncers at a nightclub, checking all data that comes in and out of the network and blocking anything that looks suspicious or unauthorized. They protect networks from unauthorized access and other security threats. So there you have it, the key components of a computer network: nodes, links, protocols, IP addresses, DNS, and firewalls. Each plays a crucial role in enabling communication between devices, transmitting data, and securing the network. These components work together to ensure smooth and secure communication between devices on a network. And with that understanding, we can delve deeper into the exciting world of computer networks. Stay tuned. Now, not all networks are the same. There are different types of computer networks. Each type of network is designed for a specific purpose and has its unique characteristics. First, let's talk about local area networks, or LANs. A LAN is a network that covers a small area, such as a single building or a group of buildings in close proximity to each other. Think about the network in your office or at your home. They're typically LANs. The devices in a LAN are interconnected using Ethernet cables or Wi-Fi. The primary purpose of a LAN is to allow devices to share resources, such as file servers, printers, or internet connections, within a localized environment. Next up, we have wide area networks, or WANs. WANs are the big guns in the world of networking. They can span large geographical areas like cities, countries, or even the entire globe. The internet, for instance, is the most famous example of a WAN. These networks are typically established using leased telecommunication circuits or satellite links. The primary purpose of a WAN is to connect multiple LANs together, enabling devices in different locations to communicate and share resources. And then we have cloud networks. In the digital age, the cloud has become a buzzword, and for a good reason. Cloud networks are hosted on public or private cloud service providers and can be accessed from anywhere in the world as long as there's an internet connection. The primary use of cloud networks is to provide scalable and on-demand network resources, such as storage or processing power, to users or organizations. So there you have it. From the LAN in your home to the WAN that spans the globe and the cloud network that's accessible anywhere, anytime, these are the different types of networks that make our interconnected world possible. From small office networks to global internet connections, these types of networks cover a wide range of scales. But why do we need computer networks? Why are they so important? Let's delve into that. In our increasingly digital world, computer networks have become the backbone of almost every aspect of our lives. From sending an email to streaming our favorite shows, these networks make it all possible. Firstly, let's talk about data sharing. Without computer networks, sharing and accessing information would be a cumbersome process. We'd have to physically move data from one device to another. But with networks, we can share files, documents, and other data across devices seamlessly, whether they are in the same room or on different continents. Then there's communication. Computer networks facilitate real-time communication, be it through instant messaging, video conferencing, or social media. They allow us to stay connected with people around the world, breaking down geographical barriers and fostering global collaboration. Resource sharing is another significant advantage. Networks enable multiple devices to use the same resources, such as printers or servers, reducing costs and increasing efficiency. And let's not forget about remote access. With the rise of remote work and learning, the ability to access files and systems from anywhere has become essential. Through computer networks, we can log into our office computers from our homes or access educational materials from thousands of miles away. Moreover, computer networks also play a vital role in areas like online banking, e-commerce, remote healthcare, and more. They allow us to perform a myriad of tasks from the comfort of our homes, from shopping for groceries to consulting a doctor. And as we move towards a future with smart cities and the Internet of Things, the importance of computer networks will only continue to grow. They will be at the core of connecting devices and systems, making our lives more convenient, efficient, and connected. In a world that's increasingly interconnected, computer networks play a crucial role in our daily lives. So, we've covered a lot of ground today about computer networks. Let's take a moment to recap what we've learned. Computer networks are intricate systems that link multiple computing devices, enabling them to communicate and share resources. These devices, known as nodes, can be anything from computers, servers, printers, to routers and switches. The connections between these nodes, called links, can be established through physical wires, like fiber optics or wirelessly. One of the most crucial aspects of these networks is the protocols, sets of rules and standards that dictate how data is transmitted over a network. Protocols like TCP/IP, HTTP, and FTP are the unsung heroes that keep our online interactions smooth and seamless. We also touched on the unique numerical identifier assigned to every device on a network, the IP address. It's what enables communication between devices, essentially acting as the address of a device within the network. The Domain Name System, or DNS, translates human-readable domain names into these IP addresses, making our online navigation that much easier. And let's not forget about firewalls, the protective shields that monitor and control incoming and outgoing network traffic, keeping our networks safe from unauthorized access and other security threats. We then delved into different types of computer networks. Local area networks, or LANs, typically cover a small area like an office or a home. Wide area networks, or WNs, span larger geographic areas and connect LANs together for long-distance communication. And then there are cloud networks, hosted on public or private cloud service providers, providing an on-demand network solution. The importance of computer networks cannot be overstated. They are the backbone of our digital world, enabling communication, data sharing, and resource allocation on a global scale. Understanding how computer networks work can help us appreciate the complex systems that keep our digital world connected. So the next time you send an email or stream a video, remember the intricate network that makes it all possible.